Let's study 9th standard ICSE Physics, Chapter 8A, Numericals on Sound. Mark the ninth sum as IMP, the deadliest sum on the planet. Let's start with the first sum. The heart of a man beats 75 times a minute. For whom? I have no idea. What is its frequency? In the unitary method, 75 beats in 60 seconds. So in 1 second, how many beats? Because frequency is the number of beats or vibrations per second. So after calculation, we get it as 1.25 Hertz. They want us to find the time period, which is the reciprocal of frequency. So that's 0.8 seconds, which means one beat takes 0.8 seconds. Now the fourth sum, they've given us the speed and the frequency, and they want us to find the separation between the two consecutive compressions. That's nothing but the wavelength, one wave's length. The formula is that wavelength is equal to velocity or speed upon frequency. The values are given, they are in SI units, get the answer directly. Sixth sum, an observer A fires a gun and another observer B, who is at a distance of 1,650 meters away, hears the sound. Speed is also given, so how much time will it take? The usual formula, time is equal to distance upon speed. They are in SI units, so we get the answer as 5 seconds. There is no reflection of sound or echo, so there is no complication in this sum. It's pretty straightforward. And now the ninth sum. An observer sitting in line of two tanks, that is, the two tanks and the observer are collinear in a straight line. But don't assume that he is between the two tanks. Only a stupid person would be between two tanks firing at each other. He is watching the flashes of the two tanks at the same time, and we can assume that light is reaching him instantly. He hears a sound after 2 seconds and 3.5 seconds respectively, and the distance between the two tanks is 510 meters. So what is the speed of sound? It will be best if you draw a diagram before solving this. So here's the observer in line with tank 1 and tank 2. The distance between them is 510 meters. He hears the sound from tank 1. After 2 seconds, obviously it's closer to him. And the far away tank, well, the sound from that will take 3.5 seconds. Now, there are many ways to solve this sum. One would be to assume this distance as x, or to assume the speed of sound as x, and solve for case 1 and for case 2 and so on and so forth. But I have a very simple method here. First of all, what is the difference between the time? 1.5 seconds. That means sound takes 1.5 seconds to travel this much distance, isn't it? Which is 510 meters. I know the distance, I know the time, I can find the velocity or the speed. Velocity is distance upon time, that's 340 meters per second. Done. And now the last sum. How long will sound take to travel in an iron rail and in air? The distance is given, that's 3,300 meters. Speeds are given respectively. Well, time formula is distance upon velocity. So the time for iron will be 0.625 seconds. Obviously, less time will be taken for iron compared to air, which takes 10 seconds. And with this, the chapter is over.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.